Okay, that's okay. So in today's class, we're going to continue with our organic chemistry. But once again, we can just remind ourselves what we have done in the past. We started by looking at organic chemistry, and what we have said so far. We said the term organic comes from where? From the word organism, right?
Yes.
So, and this word organism simply means plants and animals. So that means that the chemistry of living organism is what we call organic chemistry. And what do we say about chemistry? If you can remember, we said the word chemistry simply means behavior, like properties of anything. So, for instance, if you say you are looking at my chemistry, I am tall, I have bushy hair, I don't want to cut it, I have fine, beautiful glasses for charcoal, not like I have eye problem. Then those are my properties. I am very tall, moderately tall, I am moderate inside, everything moderate. That's my chemistry. So everybody also have their own chemistry. Your behavior. What's the behavior of Coke? To be sweet. That's the chemistry of Coke. Water, no taste. That's the chemistry of that one. So when I say chemistry, I am referring to properties of that thing. So here we are looking at chemistry of living organism. That was the belief of the olden days. According to the relic of those days, organic chemistry is believed to be chemistry of living organism. But later, we had a German scientist that they called his name Friedrich Wöhler. Thank you. So according to Friedrich Wöhler, the guy was able to do some arithmetic in a test tube, and then he supplied it to certain compound, and from those compounds he was able to synthesize something that we call what? Urea. Now after synthesis of urea by Friedrich Wöhler, from things that does not even have any organic salts, we call it ammonium thiocarbonate. That's the name of the compound. So we're able to get urea from that, and there's no organic salt there. So that means that it does not make sense to think that organic compound can only come from living organisms. No. From here, we have seen that they can come from other sources too that are not living organisms. So this is a major blow on the face of that idea that before we can get what we call organic compound, we need a kind of abnormal vital force that can only come from living organisms. So because of that, we now need to get another definition for what we call organic chemistry. We now say that when we check all organic compounds that we have in this world, we notice that for you to be an organic compound, it's a must that you have one abnormal element, and that element is called what? Carbon. So that is all organic compounds contain this element carbon. It means for me to understand what we call organic chemistry, I have to understand the chemistry of carbon itself. Because carbon is the major constituent of organic compounds. So then, how do we now study chemistry of carbon? We start by considering its atomic number. We notice that if I want to study chemistry of anybody or any element, I have to look at what are the constituents of this element. For instance, there is something they call proton and neutron. You remember that?
Yes.
We say neutron has no charge, while proton has a positive charge. So that means that this central that we call the nucleus must be positively charged, and that's heavy. We now said surrounding it that we have electrons, have you? And those electrons that we have, they are what charge? They are negative. They are negatively charged. So, which means that for this carbon, we're going to have 2,4, have you? Meaning that the first shell, K shell, will take how many? 2. While the other shell is going to take 4. So, the chemistry of every element in this world is determined by the number of electrons they have in their outermost shell. Is that okay? So that means that who actually controls your behavior, we have seen now that it's carbon as an organic compound. We have not seen that, okay, how do we understand the chemistry of carbon? Who controls the behavior of carbon? We have seen that principally it is the electron that carbon has in its what? Outermost shell. So we know that there are two rules that we call one duplet, while we call the other one octet, right? This word octet referred to as what? Why the word duplet referred to as how many? As 2, yes. Now, here, what we are saying is that the very first shell in chemistry, we call it K, then we have L, we have the next shell to be M, our ABC chemistry starts from K. And this guy takes a number that we call principal quantum number 1. This one we take principal quantum number 2, principal quantum number 3, and so on like that. We now know that every shell must have minimum of 8 electrons, except K shell, which will have Maximum of 8 electrons, except K shell that should have maximum of how many? 2 electrons. So that means that if I have 2, this shell is complete, then I need 8 for every other shell. But if you look at the element carbon, it is having 2 comma what? Which is not that 8. Then elements are not stingy. We already know that the number of protons or the number of electrons. That one is okay, I mean. We remember that one. And protons are well charged. They are plus. While electrons are well charged, they are negatively charged. So if their numbers, the number of protons equals number of electrons, that means the whole system will be what? Neutral. Abi? Okay? But what about if one is smaller than the other one? The gas will no longer be neutral, it will not be atom again. But it will rather become something that we call what? Ion. Abi? So it's going to become what we call ion and no longer an atom. So what happens? How will elements complete the outermost shell? We now say, if I really want to understand chemistry, the number of electrons in the outermost shell of that person is a major factor. In the middle of 1900, we have 2 scientists. They are German. They call one of them Lewis and they call one of them Lannoy. The 2 of them, they were looking at why do we have compounds? Because everything in this world started from elements. When elements combine, we can now have something like molecules. We can now have big compounds. Why do elements join together to form all those things? The solution that those people now provided was that the reason why elements will combine together is because they want to have completely filled outermost shell. Like they want to obey duplex rule and they want to obey what? Octet rule. That if, for instance, they are having 4 electrons here, they are going to make sure that this place is either nothing or 8. Is that okay? So that was their idea. They now said, okay, the way elements now used to do this, like completing the outermost shell, is that they either gain electron or lose electron or share the electron with somebody. Now, who is going to lose electron? Somebody having 1, 2, or 3 having. Then who will share electron? The person having half. The person that will share will have half. Then who is going to gain electron? Somebody that have 5, we gain how many? 3. Somebody that have 6 income, we gain 2. Somebody that have 7 income, we gain 1. But what about somebody that have 8? It will not combine with anybody. So they don't even have any problem. That's why they are not reactive. So according to Lewis and Lannoy, in their theory, they call the name of the theory, they call it the theory of electrovalence. According to them, they believe that why elements combine with each other is because of their attempt to mimic, like to copy the configuration of, you know, meaning of configuration, arrangement of those electrons, to mimic or copy the configuration of the ones that have completely filled outermost shell. Who are those people? They are noble, they are rare, they are not common, they are not reactive, they are group 8 elements. Example is neon, like argon, like xenon, like those people. They don't like to combine at all. Why? They have completely filled outermost shell. But we know this one element as well. Hydrogen, helium. Helium has 2 electrons, have it? And it's going to occupy which shell? K shell. And how many electrons do we have in K? Do we need in K shell to be okay? We need just 2 electrons, have it? So that means for helium, it also has completely filled outermost shell. Do you understand? So when we are now having trouble with where to put helium, we notice that the behavior of helium is like that of group 8 element. Though it's having 2 electrons in its outermost shell, but we still go and join him to those 8 elements. So now, the knowledge of bonding will help us a lot to understand how organic compounds behave. Because we have seen that the major element in them is carbon. I mean, this guy called carbon is having 4 electrons, meaning he's going to be sharing electron with somebody. And in that wise, we can now see that the kind of bonding that he's going to be doing now, he will not lose electron, he will not gain electron, but he will rather what? Share. But you know that whenever you lose electron, you become positively charged. Maybe we know that. Yes. When you gain electron, you are negative. If you are positive or you are negative, you are already charged. And anything that is charged is said to be a what? Ion. I mean, we don't say ion, we say ion. If you are now plus or minus as an ion, that means you are having a positive pole or a what? Negative pole. So if I lose one electron to you and you gain one electron from me, then that means you are negative and I'm positive. If we combine, the bond will be the strongest possible bond. So that kind of bond will now be called ionic bond or electrovalent bond. So that kind of compound, they are strong because they have poles in them. So they are called what name? Because of their pole, what can we call them? We can call them because of their pole called polar compounds. Do you understand? Polar compounds have positive pole and negative pole. So all ionic and electrovalent compounds, they are all polar. But look at this guy having 4 in the atomic shell. Do you think it will do that kind of bonding? Which one will it do? Sharing. And what do we call your name when you share? Covalent. Exactly. So this covalent now, nobody lose electron, nobody gain electron. So who is now plus, who is minus? Nobody. So since there is nobody that is plus or minus, that means they are neutral. So in that case, there is no pole. So what are we going to call them? Non-polar compound. But we now also explain again that there's another situation whereby we want to have another kind of covalent, meaning a sharing of electron. If a small tiny atom go and share electron with every giant atom, people that love too much of electron, when you go and mistakenly go and share electron with them, you know you are meant to drop one and they are meant to drop one. For instance, if hydrogen, who is having 1 electron, now decide to share electron with somebody like nitrogen, who is having 1, 2, and 3 electrons in the atomic shell. If one hydrogen decides to share electron with this guy, you know the two of them, they are meant to drop it at the middle and share it that way and be having the same effect so that there won't be plus or minus. But because this nitrogen is a strongly electronegative element, is meant to drag majority of the electron to himself. And what will happen to that side? It will be partially negative. What will now happen to the hydrogen? Partially positive. So, though, are they sharing electrons or not? They are sharing. So, but do they have charge or they don't have? Yeah. They have. So, this is not, sorry, here should be minus. Because majority of negative are already close to there. So, therefore, what we have here is actually, is it covalent? Is it covalent? It's covalent, are we? Yeah, but that covalent, does it have pole? Yes. So, what should we call it? Polar covalent compound. So that means a compound that will be formed between hydrogen and nitrogen is going to be called a polar covalent compound. But not only nitrogen can do that, our oxygen can also do that, and our fluorine. So those are the 3 guys, and we call the name of that bond, we call it hydrogen bonding. We say such compound can form hydrogen bonding. They can form hydrogen bonding. So I think that was where we got to in our first part. So then in the other part, when we went again, we now extended the knowledge to, okay, what do we think about carbon? Let's think about carbon as an element now. For carbon, who is having 1s2, 2s2, and 2p what? 2p2 or 2,4. Have you? That was what we look at. We now said the guy is going to share, but the sharing with hydrogen is possible. But then that sharing, the guy is not a strong electronegative element. It's going to just be ordinary covalent. And that covalent will not have pole. So therefore it will be what? A non-polar covalent bond. Is that correct? So that means that this carbon, can we try to draw the carbon? What if the carbon is like this? Is that how the carbon looks like? 1, 1, 1, and 1. That makes sense, Abby? Yes. We now said one hydrogen who is always like this can come here and they share. Can you see? Yes. The hydrogen is already okay for the case shell. Is that true? Then what about this one? We can have another one here. Another one here. Yes. Can you all remember this thing? Yes. Then we have another one there. So that makes a lot of sense. Can you see everybody satisfied now? But this bond, what kind of, every time you see 2 electrons, they form a single line. So that's why the guy at the center is which element? Carbon. What about the guy that is up? Hydrogen. Huh? Hydrogen. What about the one here? Hydrogen. So, and we already know that your group determines the number of bonds that should touch you. If you are in group 1, how many bonds will touch you? If you are in group 2, if you are in group 3, if you are in group 4, what about if you are in group 5? Why? Because it remains just 3 to make 8. What about if you are in group 7? If you are in group 7, why is it 1? Because it remains 1 to make 8. What about if you are in group 6? So group 7 people, one bond used to touch them. We call them halogens. They form salts. They have salt formers. So they always have one bond. What about group 6? Chalcodene. They like oxygen. They call them chalcodene. That's their name. That's their general name. Group 6 anyway. You know every group have names. Like group 8, they call them group 7 halogens. Group 6 group 5, they call them nitrogen group. Because nitrogen is a representative member of that group. What about group 4? They are metalloids. They are the medium of the two. So that's why they always do share. So can you now see? What do you think about when you don't have mold? It's a weak, the bond is not going to be strong when you share. So that's why carbon always form what kind of bond? A very weak bond, a non-polar covalent bond. A non-polar covalent bond. So that is all organic compound. We automatically have what kind of bond in them? Weak bond, a covalent, non-polar covalent bond. So that means they will be very, very weak. So it means that if I want the molecule to separate, it will be fast. Imagine pouring petrol here and pouring water. Which one will disappear first? Petrol is an organic compound, so it will disappear first. So that means they should have high volatility. Can you now see that I already understand some of the behavior of organic compound now? Yes. Now, because what I want to study here, I want to study chemistry of those people. And their chemistry include, will they disappear fast? Are the bond between them strong? Will they be soluble in water? Will they not be soluble in water? Why are they behaving this